What's the difference?
Ma'am, similar when the same shape but different size, and the congruent is same shape and same size.
I'm sorry, I cannot hear you. I don't know what's happening. I cannot hear you properly. Did you guys hear him? Did somebody hear what he said?
Ma'am,
Yeah, bro.
a congruent shape is one that is the same. Congruency is when shapes are the same size and the same shape. Then similarity is when it is the same size, same shape but different size.
Okay. Are you guys able to see here?
Yes, ma'am.
Okay, guys, are you able to hear me?
Yes, ma'am.
Okay, cool. I'm sorry about that. I don't know what happened to my device. It's just kicked me out of here. I'm gonna share the screen again and action, and we will start. And are you guys able to see? Are you guys able to see?
Yes, ma'am.
Okay, cool. Thank you for confirming. I just want to enlarge these, and these are the questions that we're gonna do after we are done with the congruency of the triangles and the similarity of triangles. Now let's look at congruent triangles. So they say congruent triangles are exactly the same size, yeah? This means that all the 6 possible measurements, which is 3 sides and 3 angles, are exactly the same, okay? So that means each and every side, when you see, let's say you have triangle A and triangle B, or triangle ABC and triangle DEF, they say those 2 triangles are congruent. They simply means that they have the same size of the sides and the same measurements of the angles. Okay. Now they're saying there are 4 conditions of congruency which involve only needing to know that a particularly 3 measurements are on the same in to conclude that the triangles are congruent, okay? And they say, in other words, all 6 measurements are not necessary in order to assume congruency. So you should have at least 3 measurements of the same that are in the same order. Let's say you have triangle A and triangle the other triangle 1 and triangle 2. Let me say that, okay? So they're saying that there's no need for you to get to know all the sides of the other triangle so that you can compare with this one. And again, you need to have the thing, both the angles and the sides. So they're simply saying if you can have 3 things that are on the same side, let's say you have a side and angle and side, they're situated in the same corner or in the same positions, that would mean that you can conclude and say that the triangles are congruent. Yeah, they say to show that 2 triangles are congruent, the following notation is used. So if you see this 3 lines that you see here, they mean congruency. So when you see them, it's congruent. It's not equal to or some, excuse me, or anything else. They say, for example, we have triangle ABC congruent to triangle PQR. Ne? They say read triangle ABC is congruent to triangle Z. So this is simply how you should call it. If you see this triangle, you call it as a triangle, and then you have ABC is congruent. This is the sign for congruency, and then that is the sign for triangle. And what am I doing? Okay, let me do this. Okay, cool. Now they say the order is important too. I was telling you about that. So the order of the triangle, the order of the angles and the order of the side is very important when you are trying to conclude if whether there's congruency or not. So when written in the above format, the following conclusion can be drawn. Angle A is equals to angle P, angle B is equals to angle R, B is equal to angle Q, and then angle C is equals to angle R. And again, line AB is equals to line PQ, line BC is equals to line QR, line AC is equals to that one. So these are the 2 triangles that they are referring to, this one that you see over here, right? So you have that triangle and the other one. Now there you have the 4 conditions of congruency. The first one being side, side, side. So that means each and every side of the first triangle is equals to each and every side of the second triangle. As you see this one, they say if 3 sides of a triangle are equal, that means the angles are going to be equal as well, right? That means the triangles, both the 2 triangles are going to be congruent if all the sides are equal. And then again, we have another one. Remember that said we have 4 conditions. So the second condition is side, angle, side, SAS, right? Let's say if 2 sides and the included angle are equal in length or size to 2 sides, and the included angle of the other triangle, then the 2 triangles are equal, okay? So you should look at how the triangles are positioned, okay? You should pay a very much attention, yeah? So let's say, for example, you look at how these ones are portrayed here. So let's say, for example, we didn't have, okay, let me try to do this. Let's say, for example, we didn't have what? We didn't have, let me try to use this so that it can make more sense. Okay, cool. Okay, yes. Now let's do this. Let's say, for example, it was like this. You see there's 2 equal angles here, and there's 2 equal angles, which is this one and this one. Again, the side line AB, line DE, which is this one are equal, and then this one is equals to this one. So you see, you have three things that are equal, but this does not mean congruency, because if you look at the position of the angle in triangle ABC is not the same as the position in the triangle DEF. The other one is between the equal sides, and the other one is outside the thing. It's outside the equal side, right? So there's no congruency here. So you should pay very much attention to the position of the angles and the sides. Do you get me, guys?
Yes, ma'am.
Cool. Now, okay, we are done. Okay, that was quick. Let's see. Seems like I didn't include the other, okay, the other conditions. Okay, cool. I didn't include the other condition. So it's side, and then the other one is side, angle, side, and then the other one would be side, angle, right? So now let's say we are having, I'm just gonna have to draw them. Let's say we are having what? We are having two triangles, and then we have, let's say it's A, B, C, D, E, not E, but E, F, all right? So we have D, E, F. Now, let's say we have what? We have side, angle, side, angle, okay? So this is how a side, angle looks like, okay? Or angle, side. You can say side, angle, or angle, side. It depends on which one do you start with. So it's angle, side, or side, angle. You see, if you look at line AB and line DE are the same, BC is the same as EF or equals to EF. And again, you have what? You have angle C being equals to angle F, which are all where? Which are all on the same position or in the same position, okay? And that will mean that this thing or these triangles are congruent. This is the what? This is the third, what you call, the third thingy, guys. The third condition, right? And then let's try to get into the last condition, which is the fourth condition. So this one is what? This is what SSA or ASS. Oh, but that's wrong. Ne, guys?
Yes, ma'am.
Okay, cool. Now let's try to write the last one here. So the last one is going to be angle, side. Angle, side, which is the fourth thingy, the fourth condition. The fourth condition, let me try to draw the two triangles, and so that you can A, B, C, A, B, and C, okay? So with angle, side, so it's going to be something like this: angle, and where do we put the side? Where should we put it? Let's just put it here. Or it can be this one, eh? Any of the two, as long as it's not between here. So if it's between here, that means it's going to be angle, side, angle. So if it's angle, side, that means there must be two angles, and between those two angles that are equal, there must not be an equal line that is equal to the other triangle. So you have this angle A being equals to this one, ne? And this one being equals to this one, okay? And this side being equals to this one. This is another or the last condition for congruency in the triangle. Now, do we have any question on this part? Any question? Now let's look at similar triangles. Okay, thank you. Similar triangles. So similar triangles have the same shape, but not the same size. Same shape with not same size, yeah? There are two conditions that make triangles similar. The sides are in proportion, right? All the three angles are equal, right? The sides are in proportion and all the angles are equal. To show that two triangles are similar, you're going to look to see this thing, this notation there. Remember congruency 1, 2, 3, and then similar 1, 2, 3. Okay, you shouldn't confuse those. They say, for example, triangle ABC is similar to triangle PQR, and this is how you say it. Just say it now. And they say the order is important too, just like with the congruency. The order even here is also important. When written in the above format, then the following conclusion can be made or can be drawn. So they say angle A is equals to angle P, angle B is equals to angle Q, angle C is equals to angle R, and AB divided by PQ is equals to BC divided by QR, which is equals to that, okay? Is equals to AC divided by PR. Then they say the two ways to prove that triangles are similar is shown below. They say show all the three angles are equal. In this case, it would be enough for you to find two angles equal as the third one would be equal, because the sum of the thing of the triangle is equals to 180 degrees, because of that is the property of a triangle. The interior angles of a triangle is equals to 180 degrees, okay? And then the second one says, show that the corresponding sides are in proportion, right? Show that the sides are in proportion. So the angles are the same, but the sides are in proportion, okay? So they say all the corresponding angles are equal to each other, and then the sides we have 2, 4. If you look here, you have 2 and 4. You have 3 and 6, and then you have 4 and 2. It seems like this smaller triangle has been the length has been multiplied by 2. All the lengths have been multiplied by 2. So 2 times 2 is 4, is equals to 4. And then 3 times 2 is equals to 6, this one. And then 4 times 2 is equals to 8. So you see, it has only been enlarged. The sides have only been enlarged, but the angles are the same. All right. And now let's, do we have any question on this? But I don't think you guys are going to have a question, because you guys answered when I asked you, so you know this thing. Do you have any question? Maybe there's a question.
No, I don't know about others.
Okay, no problem. As long as you do not have question. Okay, cool. Now let's look at question 10 here. They say calculate the value of the variables marked with a small letter A to D. Your answer in the column provided for all your calculations. Now you have to tell us how did you get to your final answer. They say show all the calculations. You need to do what? You need to show how did you get to your final answer. You cannot just say A is equals to 3. You need to show how did you get to that 3. So how much is going to be equals to that angle equal to A? Or how do we get to that? Prince Gavaza, how do we get to that?
Then we will see 20 plus 90 plus 8 equals to 180 degrees, and the reason is angles on a straight line.
Yes. So we're going to say 20 degrees plus 90 degrees plus A is equals to 180 degrees. So we said angles on straight line. Okay. This is the reason. And how much is that?
70 degrees, ma'am.
70. Is it 70?
Yes, ma'am.
Okay, cool. If you say so, and that means our A is equals to what? A is equals to 70 degrees, okay? You can include another step, say 180 degrees minus what is 20 plus this? I think it's 110, eh? 110 is equals to A. Before you get here, you can show the step, né? Because it's 3 marks, so just assume that it's going to be 1, 2, and 3, okay? So you must show all the steps, all right? And let's look at 10.2. 10.2, we have B, we have B, B, and another angle here. So now, what is going to be equals to this B? Busisiwe, what's going to be our answer here? Or how do we get to the answer? How do we calculate for our answer? Busisiwe, are you able to unmute your mic? This is Busisiwe in here. Busisiwe, are you able to unmute your mic? Remember, if you don't have an idea, you can just say you've got no idea, and then we carry on with the questions. Okay, Oneya, do you know how we're gonna do this? Oneya.
I don't have an idea.
Okay, cool. Thank you. No problem. I'll show you how to do this one. So you see, they said, remember the rule that said angle, an exterior angle is equals to an exterior angle outside the triangle is equals to what? Equal to the two opposite interior angles. So this angle that you see here is equals to what? Is equals to these two when you add them together. Okay, so that means B and B are going to be this one divided by 2, right? 130 divided by 2, okay? Or another way you can do it, and the reason is going to be interior angle is equals to, exterior angle of the triangle is equals to two opposite interior angles, okay? So this angle plus this one is equals to 130. So since this one and this one is the same, so basically you're just going to divide it by 2, right? Or another way of doing it, you can, which is a long drive, you can add you can add this angle plus this one, you say equals to 180, which is going to be angles on a straight line, okay? And then you do the same thing that I did. So we say 130 degrees is equals to B plus B. Exterior angle of a triangle equals to 2 opposite angles. So it's exterior angle of triangle equals to 2 opposite angles. Okay, this is how you do it. So we have 130 degree equals to, what is B plus B is 2B, ne? So to get rid of this 2B on a yeah, you're going to divide both sides with 2. So you're going to cancel that one. B is going to cancel, 2 is going to cancel 2. Then you are left with a B, which is equals to 130 divided by 2, which is equal to, wait, 65. Is it 65? 65
Yes, ma'am.
degrees. Yes. So thank you. So therefore, our angle B for the B is equals to 65 degrees, okay? Cool. So whatever that you get here, 180 divided by that. So if you substitute your 65 here, 65 and 65, say, I don't know, let me check, 180 minus that, I think it's 50. Yeah, it's 50. So if you have 50 here, say 50 plus 65 plus 65. If you are getting something that is not 180, then that means we did something wrong, because some of the angles in a triangle is supposed to 180 degrees. So let's see, 65 plus 65 plus 50. Let's see, it's 180. So that means our answer is correct. Remember, you should also try to prove your answers, right? If they are correct. No? Now let's look at this one here. Okay, cool. Let's look at this one. Let's see who's in here now. Okay, cool. Now, do you guys know how to calculate for this one? The first thing or the first guide I can give you is to calculate C before you can calculate D, all right? Because if you have C, that means D is going to be easier for you to calculate, right? And it's just 5 marks, this one. Ghana, what's this? What's the thing? What's the total of these two must equate to? If we have AB that is parallel to this CD, what must this be equal to when you add them together? What must be the sum of the two angles?
Ma'am.
180. Did you say 180?
No, ma'am, I said 8C.
No, I mean, what should be the sum of the two angles? What I'm trying to say, let me try to wipe this so I can start afresh. If you look at this line, they're saying this line is parallel to this one, okay? And then we have a line that crosses these two lines, these two parallel lines, ne? Now, I said, remember we have a Z, we have F, we have U, ne? No, not U like that, but something like this, right? So I said, when they are here, what do we call that? When the angles are like this, what do we call them? Do you guys remember? And when the angles are positioned like this, what do we call them? And when you're having something like this, when the triangles are like this, what do we say about them? Do you guys remember? What are these angles and what are these and what are these? Do you guys remember that?
Ma'am, like what they're each called? Okay, ma'am, the one shaped like a Z is called an alternate angle.
Yes, that's correct. And then the F?
It's called a corresponding angle.
Yes, and this
the U is called co-interior angle.
Co-interior angles. And what do they say about the co-interior angles?
That, ma'am, they add up to 180 degrees.
Perfect. They add up to 180 degrees. So we have this one and this one. When you add them together, they must equate to 180 degrees. So let's see. Let's try to do this. So that means 6C minus 40 degrees plus what? Plus 2C minus 20 equals to 180 degrees. So now we're going to solve for C, right? So it's going to be 6C plus this one on there, so it's 8C, and then 40 minus 20 degrees. What is minus 40 minus 20? It's minus 60 degrees equals to 180 degrees. Now we're going to move the 60 degree to the other side, and we are left with 8C equals to 180. 180 minus that. What is 180 minus 60? Is it 120? (180 degrees minus 6). No, not minus, because when you move to the other side, it's plus. Sorry, guys. So it's 180 plus. Kamva, we mute your mic, yeah? You must mute your mic when you join the lesson. Okay, cool. So we have 8C equals to 180 plus 60 degrees. Guys, sorry, I didn't see here. It's not a plus, it's a minus. So when it crosses or when it jumps that equal sign, it changes the sign to a positive. If it's positive, negative. If it's a negative, it's a positive. In this case, the minus 60 is negative. Now when it crosses the equal sign, it changes to plus that. So we're going to have 180 degrees plus that, which is going to be, how much is it going to be? 240. Is it 240 degrees? That means our 8C is equals to 240. Now to get 3 of this 8, we're going to divide everything with 8 because we just want to be left with just C. So C is equals to 240 divided by 8. How much is it? 240 divided by 8. C is equals to 30 degrees, okay? So if C is equal to 30 degrees, that means that, what? That means here we're going to have what? We're going to have, I'm going to write it here, 6 into 30 minus 40. And how much is it, guys? 6 into 30 minus 40. What is 6 times 30? Then minus 40.
108 degrees Celsius.
180. 6 into 30.
Sorry, ma'am, can you please repeat the equation?
I said, what is 6 into 30 minus 40? 6 times 30 minus 40. If it's 180, then we did something wrong. How much is it, guys?
Ma'am, I got 140.
140. Okay, 140 can be acceptable. Now, what is 2 times 30 minus 20? So it's going to be 2 times, this is 140. 140 degrees. 2 into 30 minus 20. So this must be 40. If it's not 40, that means we did something wrong. Because when you add them together, they must equate to 180. You said how much did you get?
Ma'am, I got 40.
40. So that
40,
means
ma'am.
when you add the 2 is 180. Therefore, both of them is 180 degrees. Okay, cool. Now that we got what? Now that we got this angle, how much is it going to be our D? You said it's 140 here, and then you said it's 40 here. How much is it? Okay.
Ma'am, I think D is gonna be 140 because of vertically opposite angles.
Because of vertical opposite angles. And another way, okay, let's do this 140. And another way of doing it, you can try to get the size of this angle. So it's going to be 180 minus 40, which is 140. Ne? Which is 140. 140, wait, yes, which is 140. Now, if you have 140 here as well, because when you add this angle, this one and this one, you must get 180, because that is the sum of the angles on a straight line, yeah? So now, if you look at one, let's say, let me try to rub these. If you look at these, you have F here. You see F. So you see this angle is going to be equal to this one. You said what's the F? Is it corresponding or what did you say it was?
Ma'am, F is corresponding angles.
Corresponding, perfect. So that means you can do it, you can either treat it this way, or you can just say this is equal to that because it's alternate angles, right? So you see there's many ways of doing it, of which is cool. Now let's try to look at these triangles, right? They say which two triangles are congruent? Is it triangle ABC or triangle EDF or EDF with HIJ or ABC with HIJ? Which of the two triangles are congruent between the three triangles that I've just called here?
ABC equals to ABC congruent to DEF, man.
Triangle, you're gonna say triangle ABC is congruent to DEF, okay? And what's the condition here? Side, 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 angle, side, angle, angle, side, or side, angle, side?
Side, 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 man.
Okay. A, B, D, E, F, D, E, F. Okay, but Sisiwa, what do you think is the condition here?
Ma'am, do you mean for like the second one?
For this one.
Ma'am, the second triangle or the first one?
This one, the first one, this one.
Oh, okay.
Remember we had three conditions for congruency, right? I mean four, which is okay, let me try to do this. It was side, angle, side, which was the first one was side, side, side. That means three sides are equal. We had side, angle, side. And then we had side, side, angle. We also had angle, angle, side. There. So if you look at this, if you look at these triangles and go to this one, which okay, let me try to bring that here. Okay, let me try to do this. Because I can't. Okay, let me just do this. Let me try to move this. Okay. Yeah, don't need it. Okay. Yeah. So if you look at these two triangles, triangle ABC with DEF, and you look at the conditions that you see on the left side, side angle, and side angle side. So now I'm asking which condition meet this congruency? Guys, are you able to see?
Yes, ma'am.
Which one is like, are these two? No. Okay, are these two angles looking like these ones, or do they look like these ones? If you look at
They
them,
look like side angle side.
side angle side, perfect, that is correct. So if they ask you, why do you say that, why do you say they are congruent, you're going to say SAS, which is side angle side. So that means side for side, angle for angle, and side for side, right? And let's look at these similar triangles. They say consider the diagram below. Triangle ABC is similar to triangle DEF. So basically, what they're saying, this side is equals to this one is equal to this one, and this one is equal to this one, okay? Right? So if you wanted to prove, or if you wanted to check for the value of x, you're going to say 15 divided by what? Divided by 5 is equals to 5 is equals to 12. Wait, before I confuse myself. So this one, you're going to divide it with this one, and this one, you're going to divide it with this one. So you said 15 divided by 5 is equals to 12 divided by x is equals to 12 divided by x. So we're going to cross multiply because we want to have same denominator. So it's going to be 15 multiplied by x. So it's going to be 15x equals to what? Equals to, what is 12 times 5? Is it 60? 12 times 5. Yeah. So it's equals to 60. Now we're going to divide everything with 15. We divide it with 15. So this 15 is going to be cancelled by that one. Then you're going to have x equals to 60 divided by 15. And it's 4. Yeah, it's 4. So that means this line, x is equals to 4. X is equals to 4. And let's see if we want to get the value of these. The value of y, so we're going to say what? We're going to say, we can pick another side that we know. Let's pick let's pick, before we picked this one and this one. So because we know x, we can now take x because we have the value of x. X is equals to 4, right? So we can take 12, we can say 12 divided by x, divided by 4. 12 divided by 4 is equals to y divide. So you're going to take the one with big numbers, okay? You're taking this one. So the bigger one. So it's y divided by what? Divided by 6. Now you can cross multiply, and when you cross multiply, you end up having 12 multiplied by 6. What is 12 multiplied by 6? 72. Yeah. So 72 equals to 4y, right? 4y. So we're going to divide everything with 4, divide everything with 4 because we want to cancel the 4 next to the y. So your y is equals to 72 divided by 4, which is equals to 18. So your y is equals to 18. So if your y is equals to 18, and here they say, by what scale factor ratio is A, B, C, and large to get that one? Okay, so if you want to answer this, you're going to check. So we have 4. So it's 4, 8, 12. So it's 3. And then 5, 5, 10, 15, it's 3. If you want to check. And then 6, it's going to be, here it's 18. You're going to say 6, 12, 18. So it's 3 times. So the ratio is going to be 1:3. Okay, that is how you do it, right? Or you don't have to do for the whole thing because you have line AB and line line DF, which are similar but enlarged. The one in the triangle DF is enlarged. You can just say 15 divided by 3, which is 15 divided by 5, which is going to be 3. So that means that the scale is going to be 1:3, because if you look here, it's just 1 mark. So you don't want to waste your time trying to show how you get to this 1 mark, how to get this 1 mark, right? And do we have any question? This one we did. Do we have any question?
No, man.
No question. Okay, cool. I guess I'll see you guys. I guess I'll see you guys next time. You must enjoy your weekend, guys.
Yes, ma'am. You
Okay, thank you. Bye.